Alright, so the last example I wanted to go through, because there's one like this in your homework, and you have to read it very carefully. It's really easy to get this one wrong because you're not reading it carefully. Alright, suppose that at the age of 29 you start working for a company and they offer you two different retirement options. The first one, you will receive a lump sum of $30,000 for each year of service. So this is sort of like a simple interest. Every year in your retirement, you'll get $30,000, and that's it. Nothing more. Option 2 is a compounding case. Suppose that the company deposits $15,000 into an account that pays an interest rate, a monthly interest rate of 1%. The interest is compounded monthly. When you retire, you get whatever the balance is at the end of the account. Alright, so the first option is, again, for how many years you work, you add $30,000 to your retirement. The second option is a compounding case, and what you have to be careful of is that 1% is not an APR. That is a monthly interest rate. That's R. They're giving you R. They would already took the APR, which they didn't tell you what the APR was, and dividing it by 12. So if you work backwards, that means they're giving you 12% a year. Alright, so they're giving you R in this case. So that's the first thing that you have to be aware of. So they're giving you R instead of an annual percentage rate. They're already breaking down to 1% a month is what you get. Alright, so there's two different cases. Suppose that you retire when you're 69, and suppose you retire when you're 59. Which option is better for the 69? Which option is better for the 59? Alright, so we'll start with A first. So the years you're going to work are 40. Right? 40 years you're going to work, which means the first option, option 1, would give you 40 times the 30,000. So every year for 40 years you get 30,000. And so when you retire, you have $1,200,000 in your retirement plan, which is not a bad chunk of change. Alright, well, let's see what option 2 would give me. So suppose we did option 2, which again means our R is 0.01. Our T is 40 times our 12 months, so 480 times. You get that percentage of 1%. You get to earn 1% on your money. Your initial amount's 15,000. So if we use our compounding formula, the future balance will be 15,000 times 1 plus 0.01 raised to the 480. All right, comes out to be $1,779,715.88. So for the 69 years, option 2 is your better option. Alright, well, how much for the, again, if you retire 10 years sooner? Alright, so suppose, again, you have to choose this when you start, so you have to figure out, am I going to retire at 69 or 59? Alright, so for B, the years that you're going to work is now only 30. So for option 1, you're going to take 30 times your 30,000, which means you're going to be 900,000 at the end of your 30 years. And then figure out option 2 for the 30 years. So again, what changes is time. R is the same. What's going to change is your time. And so T changes. It's now 30 times 12. So 360 times you get to reinvest the money at 1%. Alright, and so when you plug in your future value, it's the 15,000 times 1.01 raised to the 3/6, which you'll see turns out to be a lot less. $539,244.62. Those 10 years made a big difference. In this case, you want to go with option number 1. Alright, so if you retire sooner, you're going to go with option 1. If you retire later, you wanted to go with option 2. So again, you have to make the decision early, but you decide which one was it. And the biggest thing about this one is I wanted to point out, they gave you R. Alright, they gave you the monthly interest rate, not APR. Since they gave you the monthly interest rate, it is the R in the compounding formula. Alright, we'll stop there. We finished 4.1.